influence से उतने वो सारे के सारे all those bodies, all those cosmic bodies or interstellar bodies जो होती है ना, those will be interstellar नहीं, how do you say, cosmic bodies, let's just call them cosmic bodies. Okay, so cosmic objects jo hote hai, those will be colder and colder. Okay, the farther you move away from the sun, the probability of those bodies being colder, cosmic bodies being colder, is greater. Cosmic objects being colder is greater. Okay, next, come across the interstellar medium. Once again, interstellar medium is nothing but the space that exists between the star systems in the galaxy. Okay, within the galaxy jo space exists karta hai, उसको कहेंगे interstellar medium. And then you have the Oort cloud, which is generally icy planetesimals जो भी होते हैं around the sun, वो जो orbit करते हैं around the sun, it contains that. Okay, the Oort cloud usually contains all those objects. Fine. You don't have to be mindful of every object, but जितने भी बोले गए हैं asteroids, comets, you need to be mindful of those. Remember those 5 dwarf planets that we just discussed, and remember that Ceres happens to be the largest one. उनका positioning याद रखिएगा कि Ceres asteroid belt में lie करता है. Rest of them are scattered within the Kuiper belt and the scattered disk. Okay. The next important topic. Good so far? Are we good? Okay. Next, you come to the life cycle of a sun. All right. ये important topic है, once again, because you're expected to know how the life cycle of the sun goes. All right, so sun is a star, right? And as in with everything else in the world, since whatever has a beginning also has an end. So it is not like the sun is, even though we consider, there is a general misconception among the kids that since we call the sun a never-ending source of energy, it means the sun is going to go on forever. It simply won't finish in our lifetime or in the lifetime of the next few generations, but it will come to an end. Okay, the sun will come to an end. So this is how it is going to go. The sun usually begins, rather any star is, it begins in a nebula. Okay, nebula, like we discussed yesterday, is nothing but a gas of, is nothing but a cloud of gas and dust. Okay, gas is important because gas is, it is the fission between the gas particles or other atoms of that gas that give rise to the whole process of the star. Okay, what does a star do? That because of the process of nuclear fission inside a star, nuclear fusion inside a star, what happens is that heat and light is emitted. Okay, and we term that source of heat and light as the sun or the star. Okay, हमारे लिए sun है वो, लेकिन within our solar system, but that is what a star is. All right, so this is the nebula. That is that entire cloud of gas, and उसका एक usually protostar होता है. Okay, the very first, how do you say, एक accretion में, एक mass of accretion में आपको usually एक protostar की शुरुआत मिल जाती है. All right, and then it becomes a main sequence star. We don't have to get into why it becomes a main sequence star or something. These are simply the various stages. Okay, currently our star is also pretty much a main sequence star, and then after that it becomes a red giant. Okay, and because the hydrogen is being used up and the helium is more now, the proportion of helium is more now, and so on and so forth. And later on, at the last stage would be that the sun ends up as a white dwarf. Okay, ये white dwarf जो है ये बहुत important है, because the question, the normal questions that would be asked to you would be, what is the end stage? What is the last stage of the sun? हमारे sun का last stage क्या होगा? Earth का जो sun है ना, हमारी solar system का जो sun है, उसका last stage क्या होगा? And that is a white dwarf. Okay, please remember, it is not a red giant or a yellow dwarf or a main sequence star or something like that. It is a white dwarf. The sun will end as a white dwarf. Okay. This lower thing is a much better way. See, people, what happens is normally, what gives rise to the star? The white dwarf. White. Okay. So there is the cloud of hydrogen. Okay, you have a huge cloud of hydrogen. Like I said, remember fusion ka process, right? Nuclear fusion ka process yaad hai? What happens in the process of nuclear fusion? 4 hydrogen atoms combine to form a helium atom, and in the process, heat and light is emitted. Okay. So that heat and light is what the star is, right? So now it has become a main phase star. Hydrogen is still at its core. As long as the supply of hydrogen is enough, the star will continue to emit heat and light. Okay, it is when the supply of hydrogen falls below the necessary level that the problems start to arise, which is what happens over here. Okay, instead of a hydrogen core in the third stage, what you have after billions of years, what will happen is that instead of a hydrogen core, you have a helium core. Okay, the hydrogen shell expands, but the helium core stays in place. All right, and because of that, there is a carbon core now around the hydrogen envelope. There is a proper carbon core because of all the combustion. Now एक आपको carbon core मिल जाता है, and now there is not enough hydrogen to support the entire star, right? Life star का life किस basis पे support कर सकते हैं? On what basis can you support the life of a star? It is actually the hydrogen content. Okay, if there is not enough hydrogen gas, the star is not going to survive. So this is what happens, and it becomes a red giant. All right, and finally this star will collapse, forming a white dwarf. Now this doesn't happen to every star. This is the life process of our sun. Okay, हमारे sun का life process है. कोई भी star, you know, उसका एंड स्टेज क्या होगा, इसको डिटरमिन करने के लिए हमारे पास एक साइंटिस्ट थे, मुझे उनका पूरा नाम नहीं याद, लेकिन उन्होंने चंद्रशेखर, ओके, एस चंद्रशेखर आई थिंक, तो उन्होंने प्रपोज किया था एक सर्टेन इक्वेशन, ओके, और रादर कंडीशन. तो उस कंडीशन को कहते हैं चंद्रशेखर लिमिट. ऑलराइट, तो चंद्रशेखर लिमिट डिफाइन करता है कि स्टार का मास कितना होना चाहिए. व्हाट शुड बी द मास ऑफ अ स्टार. ओरिजिनल जो स्टार है, व्हाटएवर द ओरिजिनल स्टार इज, what should be the mass of that original star, so as to determine the last stage of that star. Okay, whether it will be a white dwarf or whether it will be a, you know, some other kind of a dwarf, or it will end in a supernova. तो ये सब determine करने के लिए what should be the minimum mass of that original star. Okay, so that minimum mass is 1.4 times that of our sun. All right, हमारे सन का जितना भी मास है ना, 1.4 times the mass of our sun is actually the Chandrasekhar limit. Beyond that, if the mass of the star lies beyond 1.4 times the mass of our sun, that star will end into a supernova. Okay, and less than that, it will end into a white dwarf, which is what our sun is doing. Our sun is going to end into a white dwarf. Are we good so far, people? So please remember the Chandrasekhar limit also. Okay. If you have any questions, please post them in the chat, because I suppose you can't talk in the this anymore. All right. If you have anything to say, if you think I'm going too fast, too slow, if you haven't understood a certain, okay, thanks. Whatever it is, just let me know. Okay, in the chat. Right. Now let's consider a comparative study of the solar system. All right. When we say a comparative study of the solar system, what we'll do is we first we compare all the important aspects of every planet. Okay. And I'm not going to do a very huge comparison, because हमको सिर्फ थोड़े से points consider करने हैं यहाँ पे. Exams के लिए prepare कर रहे हैं. After the lecture, will I send a PDF in the group? Which group do you belong to? I'll send a PDF in that group. Most of the kids have this PDF actually, but nonetheless, I'll send it forward. Sanket, you need to tell me which group you belong to. Chat box mein, nahi, I don't think I can. I don't think I can send it in the chat box. There is some issue here. Last time I couldn't send it, so मैंने उसको link में नहीं डाला है. I mean, it's not on a drive. It is on a drive, but that is not how I'm sharing it. Anyways, भैया ने कहा है PDF send किए जाए आपको, drive links नहीं. That's the thing I say. I will send it on a group. Okay, मैं क्या करती हूँ ना? I'll determine what those groups are. I'll discuss with Shubham sir. Once I have an idea of what those groups are, मैं उस group पे आपको डाल दूँगी. Most of you guys will be on those groups, right? However different those groups are, I'll be able to find you on at least 2 or 3 groups. So that's okay. I'll check out. Don't worry. I'll check out with somebody at class which groups those are. If I'm not in those groups, I'll get myself added. Okay. All right. Now, Mercury. Okay, first planet that we need to consider is Mercury. Sabse chota, size-wise, sabse chota planet, the smallest one. It is also the innermost one. It's closest to the sun. Okay. Now, it has no atmosphere. All right. Okay, Akash. Actually, I'm not sure if Bhaiya recommends this system. वो Telegram वाला system जो है ना, I don't think Bhaiya recommends that. Um, yeah, okay. I keep remember. I don't know what Bhaiya's latest instruction is. If this is his latest instruction, I'll follow that. It's at least a month ago, Bhaiya had not recommended it. Okay, Mercury smallest, सबसे छोटा, सब innermost also, सबसे अंदर वाला planet. Okay, closest to the sun. No atmosphere. It is not possible to have any atmosphere, right? Because whatever the atmosphere would have existed or could have existed on Mercury is blown away by the solar winds. Remember, बहुत high intensity से solar winds blow करते हैं, charged particles which blow from the sun towards the, outwards, so in all directions. So obviously Mercury का अगर कोई atmosphere होने का plan बन भी रहा था, तो वो solar winds ने खराब कर दिया. Okay, now understand what a day means. A day on any planet is the time period for that planet, time taken for that planet to rotate around itself. Okay, please understand, people, within the solar system there are there are what, eight planets now. So all these planets rotate around themselves. Okay, वो खुद के around एक चक्कर काटते हैं, and all these planets also revolve around the sun. Okay, in elliptical orbits. So now you need to understand this, that the time taken for a planet to rotate around itself, खुद के around चक्कर लगाने के लिए जो time लेता है, that is called as a day of that planet. Okay, and a year for that planet would be the time taken for the planet to revolve around the sun. All right, so if that planet, suppose this is the sun. Okay, ये sun है and ये mercury है. Okay, तो mercury खुद के around जो चक्कर लगाएगा, that will be called as its day. Okay, लेकिन ये mercury जो sun के around चक्कर लगाता है, that will be called as the year of the mercury. Okay, the time taken for mercury to revolve around the sun will be called as a year on mercury, whereas a day on mercury would be the time taken by mercury to revolve around itself. All right, अभी हर planet का अपनी अपनी speed, density, size के हिसाब से अलग अलग day and year होता है. Okay, it is not necessary that all the planets will have similar days and similar years. It makes sense. एक logic लगा सकते हैं आप कि जितना planet sun से दूर होगा, say suppose Mercury, Venus, Earth, Mars, है ना, तो the farther the planet is from the sun, you can clearly make out कि उसका जो orbit है वो बड़ा होगा, right? The orbit to revolve around the sun will clearly be greater. So the years जो है, years of these planets, that can have a logical progression. Okay, the planet which is closer to the sun will obviously have a lesser year, छोटा year होगा as compared to the planet which is farthest from the sun. Okay, so is this okay? यहाँ तक ठीक है. But days जो होते हैं, meaning उनका individual rotation speed जो है, the individual rotation speed of the planets, that can differ based on what that individual characteristics of those planets are. ठीक है? So okay, thank you, Vijay. तो ये Mercury जो है, the day on Mercury, meaning the time that it takes to rotate around itself, is calculated. अभी हम Earth days में calculate करते हैं. 24 hours make one day. इस ऐसे Earth days में calculate करते हैं. Okay, so one day on Mercury is 58.65 Earth days. All right, and 1 year on Mercury is 88 Earth days. Okay, Earth के days माने वो 24 hours वाला one day ऐसा वाला system से calculate कर रहे हैं. Okay, so one day on Mercury, the time that it takes to rotate around itself is 58.65 Earth days, which is 58.65 times more than that of Earth. All right, whereas a year is 88 days. Clearly छोटा है क्योंकि it is हमको 365 days लगते हैं. Mercury takes just 88 days. Okay, it is still faster because उसके लिए obviously थोड़ा कम distance है उसको traverse करने के लिए. It has the fastest revolution or the shortest year, and clearly Mercury की एक और बहुत important खासियत है maximum diurnal temperature range. Okay, maximum diurnal temperature range मतलब during अभी वो rotate कर रहा है, right? तो उसका जो within a day जो उसका maximum and minimum temperature है within a day, that will be clearly the largest. Okay, because it is closest to the sun यार, and so obviously उसका जो opposite side होगा वो coldest होगा, right? See, this side faces the sun. Okay, ये रहा Mercury. Okay, तो उसका ये वाला जो side है, left hand side जो है अभी वो sun को face करता है, तो clearly यहाँ पे temperature बहुत कम ज्यादा होगा. लेकिन ये side में temperature नहीं है right side में, तो clearly यहाँ पे आपको बहुत ज्यादा temperature difference मिलने वाला है. All right, so that is how this whole system works. तो Mercury पे maximum diurnal temperature range मिलता है आपको. People, I'm going to stop here and I'm going to try to get all 40 minutes of my lecture from tomorrow, let's make it a proper honest effort, okay, from tomorrow. And because I don't want to introduce a new topic and have the lecture interrupted. So thank you very much for joining me, and I'll see you guys tomorrow. Okay, thank you. Bye 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 people. And when do I share the PDF? When am I going to start? To पॉलिटी, अच्छा यार आप ऐसे ओके, पता नहीं यार, पता नहीं आपको पॉलिटी रूपल मैम पढ़ा रहे ना. आई लव हाउ यू गाइस कम ऐसे दो में आ जाते हैं आप. बाय बाय पीपल, बाय. I'll discuss this with भैया and we'll come to a conclusion then. Yeah, okay, ठीक है. Thank you again, thank you so much. Take care, good night, bye. Yeah, sure. Let's do that.